Hello everyone, let us see in last lecture we have seen the definition of exact differential equation and how to solve those exact differential equation. The formula for that is integration of m dx plus integration of n dy terms free from x and y constant is equal to c. It is a formula for exact differential equation. Before that you have to check this condition whether m by dA by y and m by dA by x are same or not. Okay, now let us move to the next example of same type. This is the example: solve x raised to 4 minus 2xy square plus y raised to 4 dx minus 2x square y minus 4xy cube plus sin y into dy is equal to 0. Okay, now comparing m and n, this is your m as it is, and while taking n, this minus side is of this term. That's why while taking n, be careful that minus sign should be taken. That's why it becomes minus 2x square y. This minus becomes plus 4xy cube. This minus plus becomes minus sin y is your n. Okay, now take the derivative of m. Next step will be taking derivative of m with respect to y. Here y, this is x is a constant, derivative is 0. Here y square is there, this is constant. Y square derivative is 2y, 2 2's of minus 4xy plus y raised to 4 derivative with respect to y is 4y cube. Okay, now dA by n by dA by x, n derivative with respect to x. It's a here x square derivative is 2x, that's why minus 2 2's of 4xy, and here x derivative is 1 plus 4y cube as it is. Sin y is a constant with respect to x, that's why derivative is 0. Okay, if you observe these two are same. That's why dA by m by dA by y is equal to dA by n by dA by x, which is a exact differential equation. And once we come to know this is exact differential equation, we know the formula for solving this exact differential equation. Okay, terms free from x, you have to take this only minus sign. Terms free from x are only minus sign. Take the sign with that sign. Okay, and integration of m, which is very easy. Okay, taking y constant, don't forget that. Answer is this. Okay, solve this homework for you. Okay, next, y e raised to x into y dx plus x e raised to xy plus 2y into dy is equal to 0. This is m, this is n. Okay, coefficient of dx is m, coefficient of dy is n. Now take dA by m by dA by y. M derivative with respect to y, x is constant. Therefore, here is product of two terms, and both the term contain this is y, and into e raised to bindis is also contain y. That's why we have to make u into v rule of derivative. Therefore, u into y into e raised to x into y derivative is exponential into derivative of this should be multiplied with respect to y, that is x. Okay, y derivative is 1, x is a constant, plus v into v is e raised to x into y, derivative of y with respect to y is 1. U into v rule over here. Therefore, answer is x into y e raised to xy plus e raised to xy. Now, derivative of n with respect to x we have to do. Again, product rule we have to use this. U into x into derivative of e raised to xy with respect to now x is e raised to xy into derivative of x into y should be multiplied with respect to x, that is y is a constant. Okay, plus e raised to x into y, v into derivative of x is 1, and this 2y with respect to derivative x, with respect to x, derivative of 2y is 0. Okay, it's a constant. Therefore, it becomes x into y e raised to plus e raised to. If you observe these two are same. Therefore, given differential equation is exact differential equation or exact equation, and solution is integration of m dx plus integration of n dy is equal to c, where y constant and terms free from x. Put this value of m here, we get integration of y into e raised to x into y dx, y constant plus those term of n which are free from x, means non-x terms is only this. 2y. Therefore, it contains only 2y is equal to c. Now here y is constant, that's why take outside of the integration. E raised to x into y integration is exponential upon derivative of x into y should be divided with respect to x is y, because y is a constant, plus 2 as it is derivative of integration of y is y square by 2. 2 gets cancelled, y gets cancelled, answer is e raised to xy plus y square is equal to c is our solution. Let us see next some more examples of different derivatives and integrations. Sec x into tan x into tan y minus e raised to x into dx plus sec x sec square y dy is equal to 0. Comparing m into, before that start with this. Comparing this example with our exact form, m is this bracket and n is this term. Okay, coefficient of dy is n, coefficient of dx is m. Now take derivative of m with respect to y. Okay, that's why sec x tan x is a constant, put as it is, tan x derivative is sec square y, and with respect to y e raised to x derivative is 0. Now n derivative with respect to x is sec square y, keep it as it is, sec x derivative is sec x tan x. Okay, now if you observe these two are same, therefore this is a exact differential equation, and we know solution is integration of m dx plus integration of n dy. M y constant, while taking n you have to take the terms which are free from x. Keep put the value of m here, dx, y constant, and those term of n which are free from x. There is only one term which again contain x, that's why here 0 is equal to c. Now y is constant, we have to solve this integration. Y is constant, take tan y outside, integration of sec x tan x dx, and we know integration of sec x tan x is sec x in next step. Now integration of e raised to x with respect to x is e raised to x. This is 0 is equal to c, and this integration is sec x. Okay, now let us see next. This is a homework for you. These are two homeworks. This is m dx plus this is n dy. This is m, this is n, and solve this equation by using this method. This is a homework and this is the answer for this. Again this is also a homework. This bracket x dx minus this bracket y dy. Take this x and y inside to this bracket to define m and n, and they solve the equation. I don't have any answer for this, just tally within yourself. Okay, this is again homework for you. Okay, in some examples they have given like this. Okay, in linear example also, the linear example contains dy by dx or dx by dy, but linear exam doesn't contain this type of big terms. Whenever such type of big addition terms are there, remember that those examples can be solved by exact differential equation. We have to see whether those are exact or not. Okay, therefore cross multiply. First of all, we have to, because our form is m dx plus n dy, that's why we have to cross multiply and make this example into m dx plus n dy form. So that cross multiply we get dx into this or dy into this plus this into dx whole divided by multiplication of these two is equal to 0. Take this term on this side, it is 0. There is no any need to write this denominator because RHS side is 0. Now take this dx term first and dy term second is equal to 0. Now you can define this is m, this is n. Okay, now take the derivative, m derivative with respect to y. Y is here, cos x is constant, y derivative is 1 plus sin y derivative is cos y, y derivative is 1. Now n derivative with respect to x, sin x derivative is cos x derivative is 1, cos y constant plus x derivative is 1. If you observe these two are same. Therefore, given equation is exact differential equation. Therefore, solution is integration of m dx plus integration of n dy is equal to c. Your y is constant, terms free from x as it is. You have to write down each and every time this formula. Formula has particular reservation of marks. Okay. Now put this value of m. This is m dx, y constant, and those term of n which are free from x. There is no any term which is not containing x. Every term contains x. That's why 0 is equal to c. Now y constant, take outside, cos x integration is sin x, plus again y constant, sin y is a constant, take outside, integration of 1 is x. Again y constant, take y outside, integration of 1 is x, is equal to c. Therefore solution is this. Okay. Now let us see next example. 2x upon y cube dx plus y cube minus 3x square upon y raised to 4 dy is equal to 0. Obviously this is m, this is n. Split this n. M is easy. Split this m. Y cube upon y raised to 4 is 1 by y minus 3x square upon y raised to 4. Why we are splitting this? Because we are going to take a derivative. Okay, that's why. Therefore, m derivative now we have to take with respect to y. Dou by m by dou by y is equal to 2x is a constant. Here 2x is constant. With respect to y, 1 upon y cube derivative means y raised to minus 3 derivative is minus 3, y raised to minus 3 minus 1, that is minus 4. The answer is 3 2 is a minus 6x, and negative denominator comes to denominator, it becomes positive, y raised to 4. And now dou by n by dou by x. N derivative with respect to x. This is a constant. With respect to x, its derivative is 0. And with respect to x, x square minus 3 by y raised to 4 is constant. X square derivative is only 2x. Therefore, this becomes minus 6x upon y raised to 4. If you observe these two are same. Therefore, this given equation is exact differential equation. Now, the solution is as it is this formula. Put these values of m here, y constant, and terms of n which are free from x. There is only one term which is free from x is 1 by y. This contain x, that's why we have to neglect this term. Only this contain, this is the only term which is free from x. That's why 1 upon y should be there in n. 1 upon it's not y square, it's only y. Okay. Therefore, log y is the answer for 1 by y. Take with respect to x, 2 upon y cube is a constant. X integration is x square by 2 plus 1 upon y, the integration is log y is equal to c. 2 gets cancelled. Therefore, x square upon y cube plus log y is equal to c is our answer. Okay. Now, these are some examples we have seen of exact differential equation. Now, like a linear differential equation, the pattern is same. We have seen linear differential equation, then reducible linear differential equation, Bernoulli, that is Bernoulli equation, and substitution method also. Now we have seen exact differential equation, and now we are going to see the reducible exact differential equation. The examples which are not exact differential equation, we have to reduce them first into exact differential equation by finding out the proper integrating factor. How to find out those integrating factor? Those are particular formulas. And after finding integrating factor, we have to multiply the given non-exact equation with that integrating factor both side. It becomes the exact differential equation. And once it becomes the exact differential equation, we know how to solve that. Okay. Now let's see theory first. Equations reducible to exact equation. Okay, when the given differential equation is becomes exact when it satisfies this condition, del by m by del by y is equal to del by n by del by x. If del by m by del by y is not equal to del by n by del by x, then given differential equation is non-exact differential equation. To convert given non-exact equation into exact equation, multiply the given equation by proper integrating factor, that is if, and then given equation becomes exact differential equation with new m and n, and then solve the equation by using earlier solution. This formula we know. Okay, now let us see the methods of finding proper integrating factor. Okay, these are the four methods. These are very easy methods. Whatever the example is there in the exam, we have to make sure which type of example is that to find out the integrating factor, whether that example is this or this. Okay, start with the number one um, um, no, integrating factor. If suppose first, if m dx plus n dy is equal to 0 is homogeneous equation. Homogeneous means what? Every degree of each degree of each term should be same. Means what? For example, okay, these are two examples. Okay, we have to decide whether which of this example is homogeneous. Okay, there are only two terms. Okay, every term should be of same degree. Means what? Here degree of this term is 2 plus 2. Just go on adding the variable degree indices. That is the degree of that particular term. What degree of this term is? 2 plus 2 4. Degree of this term is 4. That's why in this particular example has same degree of each term. That's why same means homo. That's why it is a homogeneous equation. Okay, while this example contains 2 plus 1, degree is 3. Here degree is y raised to 1, different degrees of all the terms. That's why this is not a homogeneous equation or non-homogeneous equation. So if suppose the given differential equation is homogeneous equation, means degree of each term is same, whatever it is 2 3 4 and whatever it is, then the integrating factor of that particular non-exact equation is 1 upon mx plus ny. Okay, integrating factor is 1 upon mx plus ny. If the given equation is not homogeneous, then check the second condition. If m dx plus n dy is equal to 0 is of the form, if the given equation is of the form f of xy y dx, it means dx attached to y, and g of xy x dy means dy attached to x or x attached to dy and y attached to dx. If this equation is of this form, then the integrating factor is just replace plus by minus sign, 1 upon mx minus ny. Okay, if though if those condition fails, then see the third condition. Third condition is del by m by del by y, del by n by del by x. We already calculated in the example for non-exact and exact condition. For subtract this del by m by del by y minus del by n by del by x divided by this n as it is here, and whatever the calculation is, solve this term, and if it is becomes the function of x only, f of x means function of x, it doesn't contain y, then integrating factor becomes e raised to this function fx dx, e raised to integration of fx dx. This is the integrating factor. And if it is not f of x, then come to the fourth condition. Just reverse this term, del by n by del by x minus del by n by del by y divided by this m. Instead of n, this is m. And if it is f of y, means function of y only, it doesn't contain, it should not contain x, then integrating factor is e raised to integration of fi dy. Okay, whatever non-exact equation can be fit into one of this method only. In some example, we can solve it by two more than one conditions. So few example are of one type and at a time of three type also. But whatever our easiness or comfortness, we can solve that example with that particular method. Okay, let us move to the examples. First, solve this equation x square plus y square into dx minus xy dy. First we have to check whether the equation is exact or not. Okay, define yum. Write this sentence afterwards. Yum is equal to x square plus y square, n is equal to with sign minus xy. Okay, now del by m by del by y, derivative of m with respect to y is 2y. Okay, derivative of n with respect to x is minus y, and if you observe these two are not same. Therefore, del by m by del by y is not equal to del by n by del by x, means this is a non-exact equation. Now, to convert this non-exact equation into exact equation, we have to find out integrating factor. Okay, now out of these four conditions, we have to make sure, we have to check one by one. First, given equation should be homogeneous. See whether the equation is homogeneous or not. Degree of this term is, there are total 3 terms, 1 2 3, addition of 3 terms. Okay, now this term degree is 2, this term degree is 2, this term degree is also 1 plus 1 2, means this is a homogeneous equation. Okay, that's why we can use first condition. Okay, this is fit into first condition. Now let us move. Degree of each term of the equation is same, that is 2. That's why given equation is homogeneous. Therefore, integrating factor of this homogeneous function is 1 upon mx plus ny. This is the formula. Now put these values, m into x, that is x cube. This is m into x plus n into y. Now simplify. Take inside this x, we get x cube plus xy square minus xy square. Xy square gets cancelled. It becomes only 1 upon x square. Therefore, integrating factor is 1 upon x cube. Now, what is next step? We have to multiply the given equation. Multiply given equation by integrating factor 1 upon x cube. Both side. What we get? 1 upon x cube into this LHS side is equal to RHS side is 0 only. And it becomes now exact equation. Now we can solve it by our usual method. Therefore, take this 1 upon x cube inside. We get this term into dx minus this term into dy. This is your new m and this is your new n. Okay, and we don't need to now check again condition for that del by m by del by y. We don't need that, because already we know this is the exact equation. That's why again directly we can write down solution is this. Put this value of m here. N terms of n which are free from x is 0 here. Rest of that method is same. Now y constant, therefore 1 upon x integration is 1 upon x integration is log x, and y constant, y square take outside, x raised to minus 3 integration is x raised to minus 3 plus 1, that is minus 2 upon minus 2. X raised to n integration we have using here. This is a formula. Okay, is equal to RHS side is c. Take this minus to the middle, x square to the denominator. Solution is this. Very easy. Okay, now let us see one more example. 1 plus xy into y dx plus 1 minus xy into x dy. First take this y inside and this x inside. Call this equation number 1. Now this is m, this is n. This is del by m by del by y, that is 1 plus 2xy. Del by n by del by x, that is 1 minus 2xy. Both are different, not equal. That's why this is a non-exact equation. Now we have to find out whether this equation fit into one of the 4 condition. This is not a homogeneous equation because degree of each term is different. This degree is 1, this degree is 3, 2 plus 1. That's why it is at the first step only, it is not the homogeneous. Now we have to check whether second condition. Second condition is if is the given equation is of the form f of xy y dx, means what? Any function of xy into the y should be attached to dx and x should be attached to dy. Is there anything such like that? Yes, y dx and x dy. That's why this example is of this type, second. Therefore, integrating factor for second type is 1 upon mx minus n. Why we have to use here? Okay. Therefore, the given equation is of the form f of xy y dx plus g of xy x dy. Therefore, integrating factor is 1 upon mx minus ny. Put the value of m and n into x and into y. Now, solve this. Xy plus x square y square minus xy minus minus plus x square y square. Xy gets cancelled. X square y square add 2x square y square. Okay. Once we find integrating factor, what we have to do? Multiply the given equation 1 by this integrating factor 1 upon 2x square y square. We get 1 upon 2x square y square is in the denominator and numerator is this and this or this and this. Okay, this is our now new exact equation and we have to solve this by our usual method. Now separate out this denominator. Y, 1y gets cancelled, 1 upon 2x square y plus y square and 1x gets cancelled, 1 upon 2x dx. This is your new m and plus again simplify, split this into numerator. X1 1x gets cancelled, 1 upon 2xy square minus x square and 1y gets cancelled, 1 upon 2y dy is equal to 0. This is our new n and directly solve the equation using the formula. No need to write again derivatives. Okay, directly use the formula because it is already a exact differential equation. Okay, this is a homework for you. Let us see next. Xy square minus e raised to 1 upon x cube dx minus x square y dy is equal to 0. Call that equation number 1. This is m obviously and n is minus with sign minus x square y. Dou by m by dou by y, derivative of m with respect to y, x constant, y square derivative is 2y, x 2xy. Here x is constant, it doesn't contain y, that's why derivative is 0. Dou by n by dou by x is x square derivative is only 2xy minus 2xy. Both are different, that's why it is non-exact equation. Okay, now we have to check whether this example is first condition homogeneous. Is it homogeneous? No, it is not homogeneous because degree of this term is 3, degree of this term also 3, but we cannot measure degree of this term because it is exponential form. That way it is not homogeneous. Now second, whether it is of the form y dx x dy means dx ला y attach आहे का नाही आहे. That's why it is not of the second form itself. Now we have to make sure these two. Okay, आता ज्या वेळेला तुम्हाला डिसाईड करायचं ह्या दोन्हीपैकी कुठलं आधी चेक करायचं एक्झाममध्ये बिकॉज if the given equation is not of the type not of this type also, then remaining two conditions are the exactly slight different. Means what? If you observe this term dou by m by dou by y, dou by n by dou by x already we have to make sure this difference divided by n should be function of x or this difference reverse difference divided by m it should be function of y. आता कुठलं एक्झाम्पल आता कुठली टर्म आधी बघायची इट डिपेंड्स ऑन यम आणि एन. ऑब्झर्व दिस यम आणि ऑब्झर्व दिस एन बिकॉज आपल्याला डिवाइड करायचं आहे यम आणि एननं. वरचं न्यूमरेटर सेमच आहे, इट इज जस्ट रिवर्स. ओके, द मेन फॅक्टर इज डिव्हिजन फॅक्टर एन और यम and how to decide which term is easy one. Easy means single term. M contains double term, n contains single term. That's why this example is of the type division by n form. म्हणजे या एक्झाम्पलमध्ये यम आणि एन मध्ये कॉम्प्लिकेटेड कुठला यम आहे. कॉम्प्लिकेटेड म्हणजे मोर दॅन वन टर्म and here only one term. That's why this example can be solved by division by n factor. That's why हे आधी चेक करायचं. अंडरस्टँड दॅट. दिस इज अ शॉर्ट टेक्निक. डिव्हिजनमध्ये जे आहे त्यातलं छोटं कुठलं आहे ते बघायचं. आता छोटं या एक्झाम्पलमध्ये n आहे, म्हणून डिव्हिजन बाय n हा रूल आधी बघायचा. तोच येतो एक्झॅक्ट. ठीक आहे. लेट अस सी नाव चेक वेदर दिस इज फंक्शन ऑफ x or not. Okay. Now dabba m by dabba y minus dabba n by dabba x divided by n we have to check. And what is the answer should be function of high x. x असलं पाहिजे फक्त. Start. Dabba m by dabba y is 2xy minus dabba n by dabba x is minus 2xy divided by n. n is this minus x square y. Now solve this example and answer काय असलं पाहिजे फक्त x मध्ये असलं पाहिजे, y नसलं पाहिजे. y should be cancelled. Now 2x y is 2xy minus minus plus 2xy divided by this minus x square y. 2xy 4xy divided by minus x square y. Now x gets cancelled, y gets cancelled. Answer is minus 4 upon x. It doesn't contain y. That means it is function of x only. Understand? Therefore, what is the next step? Is all a calculation. But what is the integrating factor? E raised to fx, this function dx should be calculated. Therefore, integrating factor is e raised to fx dx. Put the value of fx minus 4 by x. Take minus 4 outside to the integration. 1 upon x integration is log x. Now take this minus 4 to the index of x, because we cannot cancel this e and log unless we remove this minus 4 using log property only. The multiplication to any number, this is a property. Log m raised to n we are using n log m. Okay. Therefore e raised to log x raised to minus 4 is there. Now e and log gets cancelled. X raised to 4 minus 4 means 1 upon x raised to 4 is our integrating factor. Once we find the integrating factor, we have to multiply the given equation 1, this call this equation number 1, by this integrating factor 1 upon x raised to 4. We get this, and once we multiply, this becomes exact equation, and we can solve this by this formula. Now simplify this, take out inside to this term, we get this new m and minus this y upon x square is n. Okay, solution is this as it is. Okay, now put this value of m here, y constant, plus terms of n which are free from x, only one term is which contain x, that's why it is 0, is equal to c. Now y is constant, y square take outside, x raised to minus 3, integration is minus 3 plus 1, that is minus 2 upon minus 2, minus integration of this as it is dx is equal to c. Call that equation number 2 because we are separately solve this integration. Let that integration is I. Let I is equal to this integration. Now again the one arithmetic and e raised to term should be put as t. This is a short technique of integration. Now put 1 upon index of exponential as t. 1 upon x cube is t. Take derivative on both sides, means x raised to minus 3 is t. Derivative is minus 3, x raised to minus 3 minus 1. Derivative is minus 4 dx is equal to dt. Take x raised to minus 4 to the denominator as positive index and minus 3 on that side. 1 upon x raised to 4 dx becomes minus 1 by t 3 dt. Put these values in the given example, we get I is equal to e raised to t, this is t, and 1 upon x raised to 4 dx becomes dt upon minus 3 or minus 1 by 3 dt. Take minus 1 by 3 outside because it is constant, and e raised to t integration is e raised to t. Again you resubstitute t as 1 upon x cube. Okay, this is the answer for this integration. Now put this value in our solution, we get this solution. This solution become, this is as it is. Take minus to the middle, x raised to minus 2 means 1 upon x square, y square as it is, minus this integration is 1 upon 3 e raised to 1 upon x cube is equal to c. Multiply both sides by minus, and again take that minus on c into any constant is c itself, constant only. Constant into any constant is constant, make that c only. Okay, that's why this is the solution.